Yo, what's up, what's up, what's up? Welcome back. Today, I want to fix the fact that metaprogramming is always wrong, and we always do it, and we always think it's going to be a good idea, and then every time it sucks. So the context for this is we were working on this dbus library because we want to, have some sort of interprocess communication when we're working with our window manager. And as part of this dbus library, we thought, wouldn't it be cool if we could call some function? Let's see if we can find an example in here. Hold on. So if we want to send some message, we might call something like player get volume, which basically goes into this guy, and he says, hey, I have some dbus connection, and in here, I'm going to send out, as the body of my message, two dbus strings back to back. And this guy, he's going to look at this type, and he's going to do some sort of serialization of that thing, right? So he's going to, hold on. I guess it's in here. He looks at the body here, and then he basically switches on the type of this thing and figures out how we should write that thing to a dbus connection. Now, what sucks here is this doesn't really work as well as you would like when you're implementing new responses or new requests and stuff. Let me try for a second. Let's pull this out and try sending something else, right? This won't work because the Spotify, which we were talking to in this scenario, doesn't really expect, he expects a certain format and stuff. But if for a second, let's pretend we wanted to do a call to something that wanted a U64 or something instead. Hold on, we need to quickly fix a couple things here. Org mprs media player 2, and this is org mprs media player 2 Spotify. This is how we talk to this guy. And then let's just quickly make sure that this is weight volume here. Okay, if I build this now and we run it, we still can get the volume of Spotify from Spotify, which is great. And if we were to go in here and say, let's throw in a U64. So just as U64 100, right? You might think that you could do this because the type signature says you can. And we go in here, we see, oh, okay, unhandled type U64 at dbus 1006, right? So here we're oh, okay, it looks like we must not have handled the U64 type. So and then you go in here, we add in U64, we go in here, and we go write U64. Write U64 doesn't exist, but we can maybe do write I64 and bitcast it, because that's the same thing. Right, and now this compiles. Now he's giving us some other errors, but there's nothing in here that says that that we can't do that, right? So what if we were to throw in some other arbitrary type? What if we were to pass in an array list? What if we were trying to pass in a hash map and think oh, if we pass in a hash map, it should auto serialize these things. This is what if we try to pass an array, but the data that we have is coming from an iterator, and we're generating the data from the iterator on the fly, but this metaprogramming auto type deduction thing only notices if we pass in slices of data, so we have to rip the iterator into a temporary buffer, pass the temporary buffer in here. It's just all it's all clunky, wrong, and hard to diagnose and hard to debug. And for what? Because then so that we can get this kind of cool serialized thing by doing A equals B, B equals all the only benefit is that it's kind of cool. Oh, and then also in this metaprogramming approach, if we want to we have all of these types that are generic types that you have to recognize in the metaprogramming path. So we end up having types like this, where we have parse array on the parse side, and he has pub const parse array marker for metaprogramming, because this is not a constant type. This is a generic type that has inner values, right? And then in here somewhere we're going to say oh, if we find a structure and that structure has a const parse array marker inside, then we must be an array. And it's what the fuck are we doing, right? What are we fucking doing? We could just do something more sane that is you just write out the top. You just write it. You write it like a normal person who writes a normal code. And so that's what I want to do today is I want to explore what the like non-meta programming version of this API looks like and like see if it makes sense and if it's better, and then we can compare at the end. You know, that's kind of the goal. So, oopies, I closed my thing. Let's get moving and grooving. Set no number, set line break. Okay, so the way this works right now, we call dbus connection call with a bunch of stuff. Can we undo this back to like the correct type? So this guy is trying to send out a couple strings to this guy. He's trying to say, hey, can I get a property on MPRIS player, Media2 player? I'm trying to get the volume property from this thing. That's what he's saying. So 2 strings. What does this guy do? He generates some dbus header. He kind of allocates an ID for like to say, hey, when you respond, could you like give us this number back so that we can dispatch correctly? And then he calls. So one of these things is generate the header, and then he serializes the body. The body serialization is like all of this shit. We write some bytes to say, hey, this is my endianness, this is the message type, this is the flags. So this is, oh, I see. This is, we are serializing the message into some buffer using my stashed values here. And then at the end of this, we go, okay, let's write the body out. So this is the part that's doing the metaprogramming right now. We should note that he needs to pre-generate a dbus signature for this type, right? So like if I'm sending an array of structures with 2 fields, that the dbus type string for that thing looks like you start with an A for array, you open a bracket to say I'm a struct, you throw a couple S's in there, each S means 1 string, so this would be like 6 strings, this is 2 strings, this is close the struct, right? So he's kind of like sending this signature, and the signature has to match the data, or else he doesn't know how to interpret the data. Or like in some cases we might just like check that the thing that we expect is the type string that we got from the other side. So that's one thing we have to do here. We also have to pre-calculate the size, I believe. So I think when we generate our header, I think we actually pass in the body and we use it to generate the signature. And then we also use it to generate the body length, right? So we do a discarding writer and then we serialize twice. Okay, cool. Then what happens? We go into this like type deduction thing, and all this really does is he says, I'm gonna like write out values according to like what the types are in the structure, right? So if I see a I64, I write an I64. If I see a U64, I write a U64, right? Like if I see a floating point 64, I write an F64. Easy peasy. But it seems kind of like there's kind of like 3 things that we are using metaprogramming for right now, I believe. The 3 things would be, generate type string. That's one responsibility. I guess we should write this over here. Required responsibilities, we'll say, or responsibilities maybe. We have generate type string, calculate serialized length, and actually serialized data. Right? That's kind of like the 3 things this thing is doing. And so what does like a generic API for this thing look like? We do have to keep in mind that we do like code generation for this type of thing, right? So when we call like get volume, this is parsed from some XML which defines all of the dbus APIs for some service, and it will kind of generate the signatures. It will generate like, you know, what is the body for this thing? What parameters do they expect? What are the types of these things, etc.? So we can be a little loose, probably, because I think that we should like expect that callers might want to manually call into this thing, but also for a lot of situations they will just call like do thing and they won't have to think about it at all. So we probably want something that's like relatively flexible, and like not easy to misuse, but it can be kind of like more on the technical side, probably. You know what I mean? Like it doesn't have to be like idiot proof, especially because like I'm the only person who uses it. So it actually does technically have to be idiot proof because I'm an idiot sometimes, but it doesn't have to be like insanely simple, if that makes sense. It just has to be like reasonable. So all of these things go through this call API usually, and what does this call API do? I guess is a question. He is going to eventually serialize some message into some IO writer, right? I'm thinking about the fact that the signature and the length, the type string and the length, these kind of go in the header, right? So you kind of have like some stuff, signature, which is like variable length. Then you have like some stuff, body len, and then body, right? So I'm kind of thinking about the fact that this stuff comes first, but like you have to serialize the stuff to know what to put in here, which is kind of odd. And also with like when all of this stuff is done with metaprogramming, you kind of have all of this information at the time of the function call. But what I'm imagining, which may or may not be like where we end up, is I kind of want like something that's like call sync. I don't know like what to call this, but like a thing that is returned by self-connection.call, where we probably pass in all of these things that we were passing in before. And then I want to do something that's like, call sync, add string or something, right? So maybe this is like body serializer is maybe a better name for this. Add string. And then we would kind of do this, right? Add string, this thing. And then we would add another string for volume, right? In this case. In this case, we would do this. And so the signature for this thing is going to end up being like SS, 2 strings. And the length for this thing is going to depend on the length of these strings. And what I'm thinking is, if we just reorder this stuff so that it goes body, like we allocate the body first, then we generate the header kind of after. I think what you could do is you could do like a vectored write, where you could do like, write vectored, and then you could pass in some sort of vectored write that just does it in the other order, right? We say like first write the header, then write the body, right? That kind of solves the problem here, where the other option here is that if we had like some API like this, where we had like some body serializer, we would have to like call it twice, once to calculate the length and once to like actually do the data serialization. Well, once to calculate the length of the type string, then once to do the data serialization, and that's kind of hairy. I think I'd rather do something like this. I think that will work. And then, so that means that like at the end here, you're gonna go like send, right? At the end of this thing. And this guy's job is gonna be responsible for like, commit length and signature, generate header, send data, right? Something like that. That's kind of like my idea right now. I think body serializer is like the wrong name for this thing. Maybe this is just a call, right? So we're like, hey, I want to create some sort of call, and here I will like write my body in here and then send it. That's not crazy. So the only thing is, like, before, we were kind of relying on the buffer of the writer, because we were kind of like upfront, we knew everything that we wanted to know. Since we don't have that anymore, I kind of think this should go into a temporary buffer, right? So maybe we have like buff here where we kind of define like the maximum length of the serialized data, and he will kind of like, as we push stuff in there, he'll like write into this buffer. Then at the end, he can also allocate the header from that buffer. Maybe he doesn't have to. And that API seems kind of reasonable, right? What about like for arrays? So if we were gonna do like some like array of things, can you just kind of do something like this? I think that you would have to do like start like mark like array elem or something. No, because the array, I guess we don't we kind of have like some sort of, this would look like 5 strings in an array, which would make this an array of strings. But you could kind of have like start struct here as well, right? And then you would kind of go like 4, 0 to 100, add me some structures that have 2 elements in them that are structs of multiple strings. And I guess what we would do is in here, we would kind of like, as we are doing the first element of the array, we might want to either auto detect the type from this, which is definitely doable, because then the user doesn't have to like care about, the caller doesn't have to care about like generating dbus type strings, or you could pass in the type string here. That's like another option. This is kind of like a cheaper, easier way to do it, especially once variants get involved. But maybe we can auto detect it, maybe. But overall, this feels reasonable. It feels reasonable if we can make something like this work. So let's kind of say, we'll kind of make something along these lines. I don't know if it's going to look exactly like this, but that looks like kind of reasonable. I think like the pieces are going to be in place there. So let's try to do our first version of this thing. So I want to implement some sort of call to. Call to, because then we can compare, we don't have to like nuke everything. And he's going to take in all the same things he used to take in, but he is not going to return a call handle anymore. He is going to take in some sort of, or he's going to return a like call serializer. And I guess he might just kind of store all this stuff. I don't know yet. So let's kind of, I'm assuming that we're going to like use these things later, because I think that we want to like deal with the body first. Maybe. Not really sure. Is this U32? I think it is. Okay. So I guess let's start call serializer. This is gonna turn into something else, by the way, probably, but we'll see. Can we do like, let's just do the simplest type thing right now, or let's just do our get volume call, right? So our get volume call has add string. Okay. I think I spelled serializer wrong here. Serializer. I think. Serializer. Yeah, that seems more right. And this is gonna return nothing, and maybe this is errorable, not sure yet. I think that this guy wants to have some sort of like type string buff. I think the maximum length of this thing is 255, because if I remember correctly, the format in dbus land is that there is, for the type string, there is 1 byte for the length, which means that the maximum length has to be 255. Or maybe this is 256 and the max index is 255. Not sure. And I guess, this guy has like the type string, and then he has the length, right? Ideally, we don't return this thing, so we can kind of allocate the type string from the buffer they pass in, right? We said that they were going to take in a buff. And so maybe we want some sort of allocator around that buffer? Maybe. Not really sure. It feels that way for now. We'll see. Okay. So let's just kind of start here, right? So and then I guess maybe type string could actually be a stood array list here. Is maybe better, because then we can kind of like push into it as we go. Feels kind of right. So alloc is going to be stood heap fixed buffer allocator. Initialize with buff. I guess we want this. I think we need to create this thing first, and then allocate the type string as well. That seems reasonable. Because otherwise the like state of the allocator wouldn't make it into here, so we have to allocate this up front, I think. And then we just stash these parameters. Okay. Cool. And then probably we have like the connection as well. So here we say like connection is self, so that we can send the thing out later. Okay, so when we add a string, I think we just do like type string append bounded of s. Right? That seems reasonable. And then we say we must have some sort of like serializer that we're using, right? So maybe this actually goes like this. Well, do we have like some sort of like yeah, I guess maybe for now this is like buff 0256, and then we have remaining is a buff from 256 onwards, right? Maybe. Now, we might want to get a little clever here because the buffer might not be long enough. So maybe using the allocator here is kind of nice if there's some sort of like remaining, right? Is there like, can we get like the rest? I guess like this, which is kind of awkward. There's like I guess we could do, I think you kind of want to maybe do this instead, where you do like buff len minus alloc end index, and then now we get all the benefits of like the type checking and the like clearing of data, etc., from the allocator if we do this. So let's call this the like body here. And maybe this is a stood IO writer. You know what I mean? That's like kind of writing along this thing. I guess maybe we want this to be like a dbus writer even. Right? Because we have this like kind of thing that sits on top of IO writer. That's this guy. So maybe that's what we do. Let's try that. So then we can say our body is a dbus message writer. Position is 0 initially, and writer is stood IO writer fixed around remaining. Right? Easy. Easy. That feels pretty good. That feels pretty good. Okay. So then we just do like self body, right? String like s. Sure. Okay. Okay. Seems kind of nice. What is this mad about? Oh, he wants us to be a reference? Oh, that's annoying. That's annoying. Fuck. I guess we do this. That's annoying. There's not a nice way to do this. There's not a nice way to do this unless we kind of do unless we allow self-reference. That might be nice. So maybe we have some sort of call serializer. Okay, we're feeling this out. We're feeling this out. And we say, hey, hit me with all of this stuff. Maybe not even. Maybe not. Maybe we literally just do this. And we don't even stash this stuff and they just pass it in later. There is no reason that this has to be done now. So maybe this is literally just a like body serializer or something. Maybe. And then maybe we pass in like the serialized body at the end. That's to call. Maybe. Right? So then we can just pass in, instead of passing in buff here, this guy just gets like body as a body serializer or something. You know what I mean? And then he can do all the stuff that he used to do up front. That's not terrible. That's not terrible. Okay. So we pass into some buffer that we're going to work with. And here, the type string, now that we are doing init pinned, this can actually just be inline like this, because we're not going to like copy it out when we move it around. I think length is maxes out at U32. Okay. And then we have type string, I guess this is type string buff, and type string is stood array list U8. Okay, this is looking like something. So here we have self writer is stood IO writer fixed round buff. We have body is something where we have pause is 0, writer is a reference to self writer. Type string buff doesn't have to be initialized, but type string does. This is an array list of U8, I guess like init buffer. So this is related to self type string buff. Beautiful. That seems nice. And length is 0. Okay. Okay. So we don't even have to implement this call to yet. We can figure this out later. And then maybe this kind of comes out here. So then in our what's a majigit, our example, we can say body is dbus body serializer. And we kind of say, yo, you are undefined here. And then body init pinned, which probably is mad because I didn't write public on this thing. Okay. Okay. And he wants his buffer. Boom. Why does this need to be errored? No, this is nothing in here that can fail. Okay. Nice. Nice. Now we can do things like add string. And the strings that we are trying to add were literally just these things. So we add this one first. And then we add this one second. Okay. Cool. Cool. Seems reasonable. And now all we need to do is do like self connection call to of this thing. So we replace it with call to. And instead of this, we pass in body. Oh yeah, wait, that works great. That works great. So in here, let's copy paste call to again. And now at this point, we have all of the data we need. Wait, this is hype. So here, body is now body serializer, and then we can call our dbus header. We'll also copy this thing for now. We'll deal with this later. But instead of taking body here as any type, he calls body serializer. Beautiful. So he doesn't have to generate the dbus signature anymore. He literally has like body type string or whatever. Items. This is the signature now. Okay. Then the length of this thing is known. He doesn't have to do a serialization here because he knows the length of it from just the body writer pause or something. Yeah. Which he doesn't. Oh, body pause, whatever. What a funny way to call that. Okay. Okay, so then in our call to down here, we do. Oh, this is the wrong call to. This guy, we call to here with our body serializer. Beautiful. All of this stuff is exactly the same. And then in to send serialize, we don't do that anymore. We literally just call like writer write all of the buffered stuff in the body serializer. Sure. Fuck it. Oh, this is. He actually wants this. Okay, we call serialize 2 as well for now. Body is a body serializer. And it's here is where we do this. It's like W IO writer maybe like this. I think it's like that. I think so. We'll see. So this is serialized 2 now with body here. Wait. Is that it for this example? Let's see. Holy shit! Wait, this actually works already. That went way smoother than I expected. So this guy, can we do like a little serialized info? We have the len is this. We have the sig is this. And so we have like body writer buffered len. And then we have the signature was what body type string items. And that should be a string. So we're expecting to see something that's like the length of this string, which is 29 plus 6. So that's like 35 plus 2 sizes, which are each 4 bytes. So that's like another 8, which is 43 plus some alignment maybe. So somewhere in the range of like 43 to 50 something. Yeah, so 47 for a 4-byte alignment, and then signatures double S. Hype, dude. Okay. Wait, that's easy peasy. So then all we have to do is add in the rest of the things that we want to support here. So if we wanted to write a struct, let's think about that. So a structure, we are going to open up the structure with an open parenthesis in the type string. And then do we have like write struct in here? What happened in the old version of this thing? The old version of this thing, when he saw a struct, would call align forwards 8, and then he would iterate over the fields of the structure. So all he has to do here is align forwards. Like this. Then we need like an end struct. And all this is going to do is like write to the type string. Because I don't think there's anything to do at the end of a structure. Okay. Beautiful. Easy. So can we find... We might want to do this on the service side. Might be easier to test this because we can kind of like return uh we can kind of like create arbitrary expected types and then return them and see how they serialize and make sure that like another program can interface with them. I think it's easier from the services side. So can we go over here and maybe I guess in here we have like call we give the return the same treatment where we have a ret2 and the body is a body serializer. And this guy calls header generate ret2 because we don't know what we're doing yet. And this guy gets the same treatment where he gets a body serializer and his signature is from body type string items like this. And this doesn't exist anymore. He doesn't have to serialize to find the length because he's already done it. And so then we can like look at body writer buffered len here. Boom. Okay. Does our body serializer have like a length field in there that we just aren't doing? Yeah, well, let's just delete this length field because we're not using it because we're using the implicit writer length. Beautiful. Beautiful. And then we have another ret2 now that calls ret2 here, and he calls serialize2 here, and then everything is happy. Easy. Easy. Okay. So can we go to our like service example? And in here, can we... Right now, we are... Okay, let's update these guys to use ret2 on all of these first. So here we have body comes from some... I guess we need a body buff. Whatever. Maybe this comes up here. And then we have body writer can come up here too, so we don't have to make the same thing over and over again. Okay. And then we can do down here body add string s. This goes here. Easy peasy. Okay, here we go. And then down here we have try body add string s as maybe. Okay. So can we run our service example, make sure that everything is working the way we expect? So if we do qdbus and we look for us, we have this service at this path, and we have this hello. Okay, cool. Cool. So now we can start like tacking on shit to this service to like try serializing other things, right? So can we go to test service XML, and in here, can we add a new method that's a structure? I guess we'll call this get structure. And the type here is going to be something that is maybe integer. I can't remember we need to look at the types. Dbus spec. Sir, I would like you to send me some data. Thank you. Thank you very much. And in here, we can look for, maybe it's like down here somewhere. Here, no, this is alignments. Here are their type tags. So let's give them a int64 and then a double. And then a byte or something. Oops. So what is it? int64 double byte. All right, sure. Fuck it. Fuck it. So now our service example needs to have get struct like this. Was that what it's called? Oh, get structure. And now we want to do something simple. We want to say start struct we want to call with what was we say? We said int64. We said double, and then byte. I don't like dead beef. Can we do cafe food? We don't kill things around here. Okay. So now we just have to implement these, like, now it's like super clear that we need these functions, right? So we're like, okay, let's have a add i64. I don't know if I like the nomenclature of add, by the way. But whatever. So this is just like this. Oh, this is, wait, this is actually so much better. This is so much nicer to work with already. I can already tell. I can already tell I like this so much more. Right. F64. And it was add byte, which is type string y. U8 goes here. Right byte. Oh my god. It's so easy. It's actually so easy. Oh, I love it. What do we call it? I64 did. Okay. Hit me with this thing. So we should have get structure, which gives us back this type of xdy. We call get structure. Ooh, he's not happy because we never actually called the return. Oopies. Oopies. I don't know how to do that, he says. I don't know how to parse that, but if we just type literal, then we get our, oh, this prints an integer form, great. But we do get double of 1, 2, 3, 4 and byte of 100. So this is probably working. Let's do like, cafe food is this. Yep, cool, easy. So fucking easy. It's so easy. So the only thing I'm like kind of concerned about now is arrays. Arrays we've not quite figured out yet, right? So can we add that to our test structure? Or test service, I should say. And in here, can we say, let's have something that gets array. And let's start simple. We'll call this get int array. And he is going to return an array of U32s. Right? So AU, just so that we have to implement another type while we're here, right? We'll call it get uint array. How about that? So if we have get uint array, this guy wants to do some sort of like start array. And an array, the first field, the first bit of an array is a 4-byte integer, unsigned integer, that says the length of the array in bytes, right? So we don't really know what this is yet until we've filled in the entire content. But we can like kind of just leave that part of the buffer empty. We can like initialize it with zeros and then like get us a pointer to the length field for later, right? Like we can kind of have like a U32 that comes out here. Now maybe it's better to like strong type that thing. So maybe we have like array tag or array key or something that we could call this, like array. Maybe we just call it array. And I wonder, maybe we want to do something like auto generate the type signature as we go. And then maybe we kind of say like, while like for 0 to 100, we have some value. Maybe some I, maybe even. And maybe we do like mark like start lm. You know what I mean? And then that can kind of tell him to like reset the signature or like reset the cursor in the signature and start checking it. Like say, okay, now everything needs to match that signature going forwards. That doesn't seem insane. That doesn't seem insane. And then we're going to have some sort of like add U32, right? Is this how we want to do it? Maybe. Let's think about this. And then we can kind of call like array finish. And this will kind of like write that shit back, like finish out the length field, maybe? This is a little confusing. There's definitely some like potential for misuse here, right? Because you might say start array and then start like serializing other stuff into the thing later, which is a little confusing. Also, like the signature of this thing needs to be related in some way. But I think that we can kind of say, hey, if you're trying to like serialize multiple things into this body at the same time, go fuck yourself. We could maybe flag in the body serializer thing that we have like an outstanding array to finish. I don't really like the idea of having to re-implement all of the same functions on array here. You know what I mean? Like being able to call like body add u32 here is kind of nice. You know what I mean? Just because like for like function reuse, that feels a lot nicer. So maybe it's like body finish array. Okay. So then this can be some sort of tag on like where to write the length. And then the only thing that is unclear is maybe the type string thing. Because like the thing is this like body add u32 and body add byte. These guys kind of like write out to the type string every time, right? And so we kind of don't want that if we're in an array. But like, maybe like the body serializer should know if he's an array. Is array the only special case? I think it is. I think an array is the only special case. Which maybe means that like we just kind of know how many arrays deep we are. So there's like an option in here where like body has like a array array count. You know, he's like, how many arrays deep am I? And we can have like a append like type string, like mark, like add type string here that takes like the type string value. I don't know like what your problem is, but I'm just gonna like instant ban you because of your name and your text content. Just kind of like go fuck yourself, you know? And maybe we have like if array count is equal to 0, we do what we were doing before, right? And otherwise, we might want to like compare. Can an array item be a struct value? Definitely. So you can kind of have like array of like, 3 strings for ass, in which case like the array item is this structure. But I think that all of that just kind of works. I think. As long as like we reset the cursor, I guess we kind of know, we want to know like if on other value, we kind of want to say like compare val with thing already in type string, right? And like if it's wrong, freak the fuck out. Right? So like if last time we wrote string and this time we write int, we should be like, what the fuck? You wrote string last time, these types don't like line up. What are we doing? You know what I mean? So maybe we like mark in here. Hold on. Like the starts of these things. You know what I mean? So like maybe in here we have like array stack. You know, he's kind of capped out at like 256 arrays deep. In reality, this should be like 2, but 256 is like insane, right? Like in reality, if you're nesting more than 2 arrays, what the fuck is your API? 256 is like literally insane. You know, something like that. Okay, so here we can kind of say like compare start is the last element in the array stack. Is that true? If I have like an array of strings, right? As um I guess every time we enter a structure, which part we're comparing with goes up 1 or something? Maybe you're good enough with count. Yeah, because the array type can only mark one. Each array can only have one element type. Does that make sense? Like ASS means an array of strings followed by a single string. Where like a bracket SS means array of structs of 2 strings. So like an array can only be of a single type. So I wonder, like, I'm back to the idea that like array. Maybe we have like compare cursor. Maybe like type string compare cursor. I don't have like a better name for this right now, but like maybe something like this, right? And this is just like an index into the type string buffer. And we can also have like array array type start is a U8 as well. And then we have array count. I feel like we have enough data with these 3 things to do everything I want. I don't really like know. It just feels like it when I type this out. So can we like play with this idea? So when we are adding this type string, it's like if array count is 0, we append to the type string. Otherwise, we look at the type string at array, like the type string compare cursor. Right? We check this. If this is not equal to val, return error, invalid type string, inconsistent type string. Okay? And we should also probably check the like length beforehand. So if self type string is greater than or equal to self type string items len, then we have the same thing. Okay, that seems good. Hi everyone, we are currently on the lookout for a dbus library for OEBA. Have you released anything else? Or you are currently on main or O15.2? I'm on O15.2. I'm of the opinion that any library I write, it will like go on the internet. But that, like, I don't want to be a library maintainer, right? So if you see this thing on the internet on my GitHub and you want to like fork it and use it for your project, feel fucking free, right? But if you're like expecting me to like provide a reasonable library for you to use that like has features that you expect and that you can like ask me for features and I'll do them, like none of that, right? Like there will probably never be a release, right? This will be something that I use for my purposes, and like if that's helpful for you, great. But if it's not, then like, you know, you're a developer, you can figure it out. You know what I mean? That's kind of like my opinion. And like, and you know, as a result of that, you shouldn't expect any like API stability. You shouldn't expect like anything. You should like expect it to break. But that being said, I am going to use it for me, so there we know that it will fulfill at least one use case. Okay. So then I guess we say type string compare cursor plus equals 1. Probably saturating add. Probably. I guess if self type string compare cursor I don't know what I want to do here. I think this has to be bigger than U8. We'll just write usize here because I'm too stupid. And we'll say, then this will automatically all work. This will automatically work, I think. Okay. So then we replace all of these type string append boundeds with our thing. So array count starts at 0, array type start is equal to 0, and type string compare cursor equals 0. I think we only flag the type start. This might be wrong. This array type start might need to be a an array list. Not sure yet. But let's start by replacing all of these type string accesses with add type string. So this is like add type string on all of these. Boom, 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 boom. Okay. I know you don't Rust for Zig any reason. Yeah, I wrote a lot of Rust. I wrote like 10 years of Rust. And I think my attitude on programming has kind of changed over time. I think when I was like a young lad and I ate 4 dozen eggs. What does that guy say in the Beauty and the Beast? When I was a lad, I ate 12 dozen eggs. You know, whatever. But also, when I was a young developer, I was very of the opinion that every piece of code that you use should be like impossible to use incorrectly from the outside. Right? Because like as a younger developer, I didn't have the experience to know what is reasonable and what is expected and what like the conventions of things are and like how to check if my expectations match reality and all of these things, right? I just didn't have like enough knowledge to the point where it's like, oh, I just want to use this thing and I want it to be impossible to misuse, right? Rust is like very good for that type of thing because like, you know, just like the community kind of like loves like the borrow checker kind of like brings you into this world where you're expecting like everything to be kind of nicely packaged for you, and so the community writes libraries that are also nicely packaged for you and all that stuff. So there's that, but that comes at like the cost of, how do I say this, maintaining that is more work. And so Rust is like pretty good for this because at least it like won't let you do it wrong, but it means that if you're trying to make like a relatively small change, that will like propagate throughout your code base, and you have to like create like a fully finished thing every time you want to try something. And the way I like to code now is like I like to try things and iterate on them and kind of like start with like a skeleton of something and refine it until it kind of fits something sane. And Rust just gets in the way. It gets in the way. So Zig kind of provides a lot of the like safety nets without a lot of the downside. So it's not as safe. It's not as strict. You can kind of do more what you want, but you know, it kind of works. You know, it works for me now. Sorry, brother, a 3-minute ad. Well, get fucked, I guess. Well, that sucks. What you gonna do? I answered the question though, and I'm not gonna answer it again because this is getting recorded, and I don't want to, you know, bore people. But apologies. It was an interesting question. Unfortunately for you, you just didn't get the answer. Okay. So I think that we kind of want like array stack here. And I think that I want an array list of like where like the type string indexes start. So like type string starts, which means that we kind of want like an array stack buff here, and we have that same like thing as before. Array stack, we're gonna do init buffer with self array stack buff or something. I feel like I don't really know. We will see. So when we start an array, we have like array stack append. I guess like the type string len. A generic add int might be useful to take some add type int value, which switch on the type and call the underlying types like add i64, add byte, etc. Likewise, an add float. What does the title say? Meta programming is always wrong. Meta programming is always wrong. You can't trick me. You can't trick me into starting to meta program again. We are already. This is what we're trying to avoid. You can't trick me like that. I see what you're doing. What's going on here? Why is he mad? Array stack items len here. He wouldn't know how, and he was okay. No, you can't trick me. You can't trick me. Can I ask you to repeat yourself on this question? No, I apologize. You just like you asked you a question and I gave you an answer, but unfortunately, the ad just kind of fucked us. But I don't want to say it again because it was like a 2-minute answer, and I don't want that I don't want everybody else who heard it to have to hear it again. So I apologize. But it is what it is. You can maybe get it in the VOD later when it goes up on YouTube. At around 1 hour and 2 minutes, a little before there. Apologies. But yeah, it will be on YouTube though. Later. Okay. So when we end an array, what happens? You're writing a metaprogram that generates type strings right now? I don't think so. At least not by my definition of metaprogramming. Okay, so when we end an array, I guess we look at this and probably error, no array if there's nothing in there. And I think that we want to like maybe do some sort of like start array elem, right? And I feel like this thing, like he sets the type string compare cursor to the thing at the back of the array stack. No array or something. You know what I mean? Something like this? Yeah. I think that might work. It might. So when we go back to our like service example, this guy should have almost everything he needs now, right? I guess the end array needs to have the like array tag. So we're gonna have like a array tag here. And this is just going to be literally a U32 pointer, right? That's what we said before? Like count field is a U32, right? And I guess we're gonna just say like, I guess we need to write down where the array started, right? So this is kind of like field start is an index into the writer, and then this is going to be the tag start as well. We have 2 fields in here: field start, like content start, data start, and tag start. Type start. Okay. Yeah. So then when we start an array, I think we actually have to align forwards first, by the way. Maybe not. Oh, does the length skip the first alignment? That sucks if it does. I guess we'll find out. If it does, that makes our lives a lot harder. You have to like, yeah, you have to like handle that somewhere. I think. Oh, but we'll see. Um, sure. We'll kind of ignore that part for now, and then we'll come back and get mad later. So this guy's going to write down not just this thing. So this is like type start is this, but the content start or data start is that what we called it is writer end, where this guy is right now and where this guy is right now. Beautiful. So now when he ends the array, we'll say like data is this. And then that means that like technically this tag doesn't have to get returned because he can actually also store the like size pointer. Oh, wait, yeah, this is height. Okay, so when we start the array, we say like self writer or self body write u32, and we just write this is 0, right? We say that the pointer, like the len pointer, size pointer, is this guy like aligns forwards. So this is like gonna like work into the underlying writer. So we're gonna go like back by 4, right? So we have like current buffered is this. Then the size pointer is current buffered at current buffered len -4. So this is kind of nasty, but whatever, we can live. We'll just put a fix me. Ew. But I think this does the right thing. I think. And so now all we say, we don't need to tag this thing. We just say data size is equal to the data start subtracted from where we are right now. So we just have writer and minus. Oh, beautiful. This is so easy. We probably have to stud mem. What is it? Math cast, or else return error invalid len, or like array too long, or something like that. You know, this is feeling pretty good. This is data type start or something now. Okay. Okay, so now what do we say? We say array body start array. For each thing, we say body start array elm, like this. Does this thing fail ever? Yes. Okay. And then we say body add u32, which we did not make yet, but we can make easily. Add u32 takes in a u32. The type string for u32 is a u, beautiful, and then it's write u32. So we mark each element, we add a u32, we finish array, or is it end array? And then we return it. Okay. Beautiful. True, huh? So we want like array stack item is a structure like this that gets this stuff because we need to name it so that we can use it in two places here and here. Okay. So we should have get uint array. Who he is not happy because we have some incorrect alignment on this pointer cast. Interesting. Okay. I thought that would work. Oh, this can't be a pointer to U32 because the data is aligned within the buffer, but the buffer is not necessarily aligned itself. So this is more like this. A pointer to 4 U8s, I think, is maybe more correct. Okay? But she doesn't like for some reason. Maybe an and here? Wait, what is it? Is it slice of non-array type U8? Oh, oops. There we go. And then this thing needs to be a pointer to 4 U8s. And then when we write it in here... Wait, what's the problem now? Pointer to 4... What the fuck are you complaining about? Expected U32? No, it says 4 U8 right here. I see it. Here we go. So then when we write this thing, we cast this like this, and then we write it into data size. We have like std mem. What is it? There's some function in here to like, I guess it's like memcopy into data size, and we're looking at like std mem as bytes size u32. I think that's right. Access unit field pointer while int is active. My bad. My bad. Okay, let's try this again. Now we are mad because we have inconsistent type string. Okay. Okay. So can we look at this? So this is our type string compare cursor. Get set here when we start array elem. Okay. Oh, because we need to check if obviously the first element that gets written needs to write the type string, right? So we've kind of got a mistake in here, huh? Okay. So how do we do that? I guess we probably want to store in this thing, whatever the fuck it is, like tag state. So we can either be initializing or comparing, right? And we start in the initializing state, I guess. Was it called tag state? I already forgot. Yeah. And so then we say, I guess this is like data is self array stack get last or null or else. So in the case where this is empty, we do the default thing, and we return default case, and then we have this data thing. This is the like in array case, you know, something like this where we do this stuff now, but we're gonna switch now on the data tag state. And if this is in comparing, we do this, whatever the fuck we were doing before. But if we are initializing, we literally just do this. We just append to the type string. Okay. And then we need to make it so that when we start array element, we say, I guess like our first state, we need 3 states, I think. And like initializing, writing, comparing. So then we can kind of say, initializing, return error, like invalid state, which means that like you didn't start your first array element. Then if you're in the writing state, you append. And then we can kind of say like here, depending on our data, you know, if we are in initializing state, we immediately move into this is like type state or whatever, tag state. The tag state immediately goes to writing. If we are in writing, we have finished writing. When we start the next thing, we're going to comparing, and if we're in comparing, we do nothing. We are in our current state. Now this thing, get last or null, returns the value. I want like, is there like get last pointer null? Get no pointer. No, okay. So this is like if array stack items len is equal to 0, we return error no array. Then we look at self array stack items len -1. We grab a pointer to this thing and we say this is data. Then now data is mutable and everyone is happy. Okay. That's like a maybe. What are we looking for? QDBus. Info. IO failure shutting down. That's not helpful. IO failure. Okay, so we got end of stream or write failed here, which is interesting. It might be that the buffer is too small. That's probably it. Can we allocate like a meg? Like, fuck it, you know? Let's try that. Okay. He actually is mad. Is it because, like, we don't reset the scratch ever? We do reset here. Is it that we trying to allocate a meg and we don't have one? Oh yeah, I see. Our whole buffer is a meg, so let's just like do 512k or something instead. Too big. Too big. IO failure. What the fuck? Can we see what the IO failure is? Hello? Oh, I see. I see. End of stream. I don't know, like, who's mad. This is so stupid. Can we get a backtrace here? There we go. Oh, the other end is shutting us down. The dbus service is just going like, no, you did something wrong. And he's getting mad at us. So I suspect that that's an alignment problem or something. Or maybe like an array length problem. Can we compare maybe the old and new versions? Array serialization, you know? So we're gonna make one of these. Okay? Gonna make one of these body serializers. Okay? And we are going to basically do what we were doing here. And then we want to compare it to an actual array, like previous version. This is literally going to be 100 U32s. Right, we go to level 4, 0 to 100. We have I. We say previous version I is equal to I. Int cast like this. Okay. And then can we go like dbus, like serialize? What the, is it not dbus serialize? It's not a, yeah, it is. It's a private. I see. But we should be able to go, hit me with previous version. And this should return, like, this goes into a writer. Old version buff. Okay, something like this. Right? And I guess this test can live in the actual right spot. Okay. Which means that that debug serialized inner thing doesn't have to be public anymore because it can live here. Okay. We're looking kind of close. And then we just want to do a little stud mat, like try stud testing, expect equal slices of body buff and old version buff. Except we kind of want to do like, I guess, body writer buffered and old version. We're kind of like comparing these two things. We're expecting them to be the same. Okay. So this should fail if I am correct. Oh. That's interesting. Expect false? Is this running? Okay, well, that's a good sign. I guess in the pre-stream segment, we did notice some concerning array behavior, where we actually saw Crash trying to parse an array as well. So we might be misunderstanding what an array is supposed to look like. That is very possible. Can we go back to the old? Can we actually try this with the original version? And if the original version is broken, then we can fix both at once or something. So the old version of this would look like, I guess, something similar to what we have in this test. Boom. Oops. So we're trying to put this in here. We are trying to basically just call ret with this bad boy here. I think. I think like this is what we're supposed to do. I'm not really sure. Okay, so that works, which is interesting. So somehow, that's very interesting. So according to our unit tests, wherever the fuck that was, according to our unit tests, we get the same thing here. But when we do it here, the behavior is different. Oh, fuck me. Fuck! Oh, no. Okay, so you know how at the very beginning of this whole thing, I said, you can just swap the order of the header and the body. You can serialize the whole body first, and then come back and figure out the header at the end. That might be untrue if the body is not aligned to some position. Oh no, the body has to be aligned. Actually, I remember seeing somewhere that the body is always aligned to 8 bytes. So you that never mind. That's fine. I think body. I guess it's probably message format, right? Surely. Header fields, valid names, blah blah, member names, message types. Where do they talk about the body? Yeah, the body. I'm pretty sure the body gets aligned. Pretty sure. You would never lie to us, would you? Lying is kind of fun sometimes. I don't really like lying, but I do like lying if it's funny. So I will definitely lie if I think it is funny. If it entertains me, I'll do it. But otherwise, probably not. But I can be wrong a lot too. That happens all the time. Byte order and alignment? Byte order, blah blah blah. Each volume of block of bytes is aligned naturally. 4 bytes are 4 byte. Yep. Alignment padding may be necessary. Must always be the minimum required padding. These guys are always 8 bytes. Yep. But what about the body? The body message is made up of 0 or more arguments or type values has blah blah blah. Message consists of a header and a body. Header is a block of values. Body is a separate block of values. Like the header must be a multiple of 8, allowing the body to begin on 8 byte boundary. Yep. This is what I was looking for. So I was gonna say that we don't know our alignment, but we know that we're 8 byte aligned, and the 8 byte alignment is like the maximum, so we don't have to worry about that. So then it seems to me like can we do something just real quick? Let's do a silly, and let's just assert right now. We can do. In this context, we want to double check. We want to basically run the same test that we ran in our unit tests. Right, so we kind of want to just go basically like this. And this is public now because we need to, in this context, test this thing. And we just want to make sure that we want to say, try for, I guess, std debug assert, std mem equal, this thing and this thing are the same. Right. And let's, fucking crash there if that's wrong. Interesting. So, according to this, we have the exact same fucking body, but when I do ret2 and I throw in body here instead of ret, this thing stops working, right? Very strange, right? Which means that ret2 must be doing a dummy. You know what I mean? It must be. So before, is the type string different? Maybe. If the type string's wrong, we could see this behavior. Let's take a look. Maybe. Aha! I am a fucking idiot. I'm a fucking dumb, stupid fucking idiot. And we just forgot a very crucial part of this, which is that when we start an array, we have to add the type string of an A. Let's fucking go! So arrays are working great now. And now the only thing that we need to really test here is like some form of nested array, right? And we want to make sure that like a more complicated, like a nested array of structs works correctly. So can we throw in here and we'll say get struct array first. Let's not worry about nesting yet. But let's say that we have, you know, a string, an int together, right? Easy. So get struct array is our new thing. We have, fuck this shit here. We're chilling. Fuck this shit here. Boom. Good afternoon. Good afternoon. So we do get struct array. We have start array elem, start struct, and struct. Okay. Easy. And then we said, what was it? It was a string and then an int. So add string. And we'll say the string is maybe some generated string. Maybe we just write hello because I don't really care right now. And add, was it I64? Was that our type? X, I think. I don't remember. These guys don't take anything. Then we end the array, then we return. Can we call get struct array? He is unhappy, so that's not good. Let's start here by checking what this guy made for us. You know what I mean? So can we at least... I'm worried about the type string, so can we look at the type string here? Body type string items, because I think there's a good chance that we fucked this up in some way, shape, or form. So let's just check a look at this. We got array of SX. So that is, I think, what we wrote in the XML. An array of SX. So that's good. Then I guess the concern would be that the content is wrong. So I guess we're going to do the same thing as we were doing before, and we're going to kind of pull a page out of our unit tests books. And we're going to serialize the old version. And what is our previous version? Previous struct. Right, so this is you know, we would have had an I64 in here, right? And a string. S is a dbus string. Okay. And then we would have had an array of 100 of previous struct. Okay. For old data, this is value index. We say old data at I guess it's VS is equal to hello, and then VX is equal to the index. It's kind of what we said, right? Something like this. Okay. I don't know what this is mad about, but this should be old data now. And then we should say stud debug assert stud mem equal that the new buffer data is the old buffer data. Yeah. Yeah. Something like this. And hopefully this assertion fails. It does. Okay, so that's good. So now we have like an expected failure, right? If the thing that we wrote isn't the thing that we used to write, then something's fucking wrong. And can we compare it? Can we do write buffer? So we're gonna say, let's look at the old data. And then let's look at new as well. And can we just do like a quick little helper function like write buffer? We have some data and we have a path, right? And we are trying to go like some file is tristud fs current working directory, open file, create file, I guess. At path, we close that file. Eventually, we have some like writer buffer, which is this because we do buffered writing. I guess we could just do like write all like this, and then we don't have to get all crazy with it. Okay. Okay, so now we can hex dump old.bin. And we can do new to new, and then we can do a kdiff3. Is that the easiest way to inspect this? It's an alignment issue, I think. You guys can't really see because the text is so fucking small. Can I increase the size? But it's actually like wrong right off rip. How do I fucking make this bigger? Settings, configure kdiff3, font, change font. 18. Fly. Cancel. Nope. Go back down to 10, please. This one. There we go. So we're actually seeing it wrong, like, immediately, huh? We're seeing, like... Dude, why can I not... Can you please let me look at the end of the line? Why is all software fucking garbage? Guys, it's insane, right? I should be able to scroll left and right in this buffer. Am I fucking insane? Oh my god. Okay, maybe, we just fucking open them, both of them. Right, like we see 60, 64. So there's 4 bytes incorrect here. And then, was there an alignment issue here? 500, 5000. Oh, so maybe we're counting some alignment stuff here. So this is like array length, right here. And then we are aligning to the next 4 bytes for the struct boundary. And I think that that means that the first alignment needs to be like subtracted from the array length in some way, which is annoying. Right? It means that like when we call start struct, we want to like align forwards here. And it's like you need some sort of like heal the array start, because like when we say start array, where is it? When we say start array, we write down like where the end of the integer for like the length is, but like you kind of need to write down something else. Oh, lucky for us, the only thing... Oh, there's a lot of things that are 8-byte aligned, actually. Yeah. So I'm gonna hack it for now because I don't have a better answer. However, what we should do is somehow like hook into this like align forwards in the body writer or something. Not really sure, but what I'm gonna do is I'm gonna do like heal array alignment or something. And can we actually like switch on the type of the thing that we're? Ugh, gross. What if we could do this? Last alignment gets stored in here. Then when we align forwards, last alignment is equal to alignment or something. That's stupid. That's stupid. I don't want to do that. I mean, so you definitely need to heal something, right? You need to say you want to like switch on self. I guess we say like data is self. I kind of want to do this. Function get array stack end or something. And this is going to be return optional pointer to an array stack item, right? Which is basically this. Then we have this guy is like const data is self get array stack end, or else return error no array. And now we can do the same thing here, except here it is just a return. This is not a failure. Then we can switch on the data dot tag state, and if we are in writing, initializing, we want to check if this is like the first element that's ever been written. You know what I mean? So maybe this is just like rename to state, but maybe we go to like writing first initially. Then if we're in writing first state, we like do healing, and then the tag state is writing. Otherwise, we do nothing, right? I guess it's kind of more like this. This is nicer in terms of indentation. Early returns are pretty hype. So if we want to do that, then what do? It's like heal array alignment for 8. Like so this is only going to be called on 8-byte aligned elements, right? And we'll just say if data start mod 8 is not equal to 0. I guess we like move it up. Data start plus equals this, like 8 minus this or something. It's like something like this. Maybe it's like this. Align forward. Like this. Yeah. This sounds a lot like some bogus snake oil salesman. Your array is misaligned, let me heal it for you. Yeah. Sure feels like it. What are you making? We're just kind of like trying to get the meta programming out of our dbus library because it was a pain in the ass. I didn't like it. So now we're doing something else that is not very good. Perfect. So now we can do try self heal array alignment 8 here, and on double, and on I64. And let's see if that fixes it. I'm not really happy with that solution, let's just be clear, but it's better than nothing, right? So now it works. Let's fucking go, baby. Let's fucking go. So we have arrays of structures, we have arrays of integers, we have strings. All of that is working great now. And so I guess the only thing to test is like arrays of arrays, right? So we'll call get nested struct array, which is just going to be an array of struct. Okay? And we are going to go into our service example, and we are going to, what was it? Get nested struct array. And so we are going to immediately start, I guess it's like we start array elements. So for 0 to 2, for 0 to 2, we do this. So we go new array element, and that new array element is an array. And let's maybe do j times 100 plus I here. And I think that that should kind of do everything we want it to do. I think this should be valid. Yeah. This would be crazy if this works, by the way. Of course it doesn't. It would have been crazy if it did. Will you do hash maps? Well, the point of this thing is that we don't have to do hash maps. The point of this is that we can kind of structure the code such that if we have a hash map, we can serialize it as a dbus map, but we don't have to like do the type introspection to do the same thing. We can just have a thing that's like start map, rate key, rate value, rate key, rate value, rate key, rate value, and map. You know what I mean? That's kind of the intent. Okay. So the problem here is that like the fucking dbus server just doesn't tell us what we're doing wrong. But we can maybe try to figure it out. Oh, so start array. This is a line 4. Can we look at like what type string we end up with? Also, wait, hold on. Can we also double check? If I don't call this, we see get nested struct array, which is supposed to return array of string integers. Okay. And then can we confirm that that is the thing that we think that we're sending? So can we look at body type string items and do a little std debug print of this thing? So if I rip this shit, that would be the bug, right? That would be the bug, is that we are double creating the string, the tag string. So it's because like, let me think for a second. Somewhere we're supposed to say move into this like comparing state, right? For the tag string. Where does that happen? That happens when we start a new array element. Is what's supposed to happen. Oh, wait, hold on. No, I'm lost. I'm lost. Because what we should see is we start an array. We start an array element. We start an array. We start array element. Here, we add to the type string. Oh. Oh yeah, then we call start array element again, which should move us into the comparing state. Can I... Yeah, the fact that it's printed twice is very surprising to me. Very surprising. So if we are initializing, we go to writing first. If we're in writing first, we go to comparing. Every time we start an array element. Is there an end array element? There should. I don't think so, and I don't think there should be. I don't think so. So then when we go to add type string, we get the last element on our stack. And we should be, we're writing our structure. We say, okay, this thing was in writing first. So we append our string. Oh. I mean, this is probably wrong, right? We should only move this if we're in that state. Oh, but we know we're in that state because we checked it up there. So that seems fine as well. We need to log something. I just don't know where I want to log. I don't really have any guesses as to where the bug is. I guess we just start writing, we log in add type string, right? So we say here, default case adding this. Okay. So we're we are adding this thing to the type string. And then here we'll say, writing case adding this. I don't really know what I'm expecting to see here. Because I'm expecting it to work and it's not working. So obviously any guesses here is not helpful. So we're saying default case adding an A. Now we're in the writing case and we're adding another A. Writing case adding this. Okay, that's not helpful. Can we also print the array depth right now? So maybe we're writing once for the top level array and once for the second level array. You know what I mean? I don't know why we would be doing that, but it's possible. So which array do we think that we're writing here? So both of these guys think that they're writing in writing case for the second level. For the second level of this thing. So that makes sense to some extent. Every time we type start array element, we should move out of this thing, right? So let's just log here. New elem for this depth, we'll say. Which is self array stack items len. Oopsies. Okay. Interesting. So we write out our first 100 elements. We end the array, which pops off our stack. Then we add a second array. Oh! Well, fuck me. Interesting. That's very interesting. So what's happening is we start this array, right? We go array, he has some length field, and then we say we write an A into the tag structure. We start our second array, our nested array, he gets len here, and we write another A in here, right? Then we write our data, on the first element, he writes SX here, like this. Then this whole structure gets deleted. And we do it again. Right? Now, he knows not to write the A because his parent says that he's already in comparing state. But he does not, this guy, when he's created, does not know to not write the string because his guy's in initializing state, not comparing state. But we can just fix that. So when we are creating an array, we should inherit our parent's tag state. Maybe. So we're gonna look at self array stack get last or null, or else we are in Shit. Hold on. If this thing, then we have data. In that case, we see data tag state or something. Otherwise, we are in initializing or something. Then we say, like, if parent tag state is comparing, we are in comparing state. Otherwise, we're initializing. That seems kind of right. Now, I think we're going to hit an alignment bug here because we have that, like, heal alignment thing only on the writing state. So we might also need, like, compare first or something. Let's try this for a second. Okay. So we are seeing something different now. So we see writing, adding an A, writing case, adding all this stuff. Oh, we need to set we also need to set, like, the compare state start, which is not being set. So we also need to set, like, type string compare cursor. Is equal to I don't know. I don't know. It needs to go somewhere though. It needs to go somewhere. Like, we need to start comparing with whoever he wants to compare. So, like, he's got, like, we have some type string AAASX or something, right? And, like, where does this, like, get reset to? Type string compare cursor is the array stack type start. So we literally just say, like, if we see this thing, hold on. So here we just we say self, we start comparing with the data type start. Okay, maybe that'll do it. Not sure, but we will see. Inconsistent type string. He's still unhappy. Okay. Can we see who we're comparing with? Oh, I mean, is this just the length one? Inconsistent type string. Here. So we are at the end of the type string when we shouldn't be. When we are probably pushing our structure start or something. We probably also have to set our type start to, yeah, to this, right? So, like, we reset this according to the type start every time, so we kind of need, like, to know, it's like something like this, but only if we're in the compare state. Ugh. Okay, we're gonna do this. We're gonna do some sort of, like, bullshit here where we have, like, two completely different cases here. I think that that'll make our lives easier. So if we are in some array stack and the data tag state is comparing, we have to initialize this guy a little differently. We reset the compare cursor and we also set this to wherever the fuck we are right now. Maybe. Otherwise, we do whatever the fuck we were doing before, which is we set to initializing, and we say it's time to start writing out the type. Beautiful. Let's try that. I think that's closer to right. I think somewhere did this as well. Writing case, adding a. New LM for 1. Oh, this returns in the wrong spot. My bad. My bad. We only want to return if we were already comparing. We only want to do that if we were already comparing. Okay. So now we have all this stuff. Now we have the wrong type string, but at least it's in there. So what are we comparing with? Because we probably just have like a initialization here. Comparing this with this. All right. So we got this bad boy and val. Oops. Comparing A with this. Yeah, so he's off by 1 on the initialization of the already comparing thing. Probably. All right, that's a lot better. So we finally got like the correct type string out of this. What does this function do? Great question. Who fucking knows at this point? Okay. So now we have this thing working. Now the data seems to be wrong in some way. I don't know how yet. I don't know how yet. But I think that unfortunately I'm short on time today. So getting further through this nested array case is not feasible today, unfortunately. However, I do strongly believe that the rest of this is much better than it was before, right? So if we look at like the old version of this code, we did, you know, it did look a little simpler from the caller's perspective to some extent, right? We say, oh, look, we just throw dbus string in here, easy peasy. But, you know, it was very easy to get the wrong thing in here. The serialization would be like switch on types. If you threw in a random type, you'd have to like go into the implementation to figure out what types are supported, blah, blah, blah. The new version of this, which works for most cases right now, is looks a little bit more verbose, but we have like an API that has like a big list of things that we can do, and we can kind of generate these structures from. We don't need to like create types just to like match the structure here. We can generate arrays without having to allocate the like space for those things just to copy them out later. I am like a fan of where we've ended up here. I do think this API is better. I think there's a little couple pieces to fix here. But I'm happy with the idea. I'm happy with where we got. And so I think that we can say, once again, metaprogramming is always wrong. We don't do it. This is better. I think the implementation is actually simpler. It feels like it's not because like some of the stuff we're looking at right now, I think this is like we're going to figure this out and find a way to like make it a little cleaner. But I do think that this is better than dbus serialize, where I would rather this type of complexity than like this type of complexity, you know? So I don't know. I could see it both ways. But for now I'm happy. I hear you're spreading the gospel of metaprogramming. No. It's always bad, but not like she's bad. Like it's actually bad. I don't like it. So, thanks for watching. If you like what you saw, we stream most days. We aim for 12:30 to 4 Pacific time. It is 3 now, so if you're watching live, you know, anywhere between 2.5 hours ago and an hour from now, so you should expect to see us. I'll probably be on tomorrow with a happy hour. Probably. Um, but yeah. Happy Saturday. See you guys tomorrow. YouTube, peace out, and Twitch, let's find someone to raid.